My name again is José Suárez. I'm a technology architect in Accenture Spain. I belong to the Spain ETC. And one thing that was important 2 years ago when I was proposed to work in the front-end architecture is something that is happening in a lot of projects I've been working on. But firstly, I would like to notice that I don't care anymore about the titles after 25 years working. But anyway, I'm the chapter lead of the front-end architecture in Spain and also the front-end and full stack development. And also here they are my mentors. There is something significant for today is that Jorge Hidalgo was going to come here in the next presentation in this same auditorium, but he cannot come today, so I would like to greet him from here. And also, I would like to notice that this shirt is from the front-end chapter and from the front-end community in Spain. Okay, so starting, why this talk? The first thing, when I was proposed to the leadership the chapter of the front-end and full stack, that came to my mind is front-end. No, that is a nightmare, that is a hell, that is horrible, always complexities, the problem always goes wrong. But in the end, I accepted. I'm still here 2 years ago, so because it's a lot of different things can be put in place in order to fix what is happening, more or less always. And this is something for me that is very explicit. Front-end was backend. The typical thing when something is not working, no, that is a matter for the backend. Of course, a front-end man or girl talking, and on the other side. And I would like to put here some of the common comments that I could hear during all these years. Front-end technologies are not stronger as the backend ones. So I think that is correct. Front-end is only a box, if any. We'll see later why this affirmation. Sadly, also that is a reality. JavaScript is a nightmare. I should say that front-end is not only about web applications. Front-ends are mobile applications, hybrid application, native application with Java, Objective-C, Swift. So it's not only about JavaScript, but more or less we could say that it's the most important language in the front-end. And this is something very nice from Java people mainly. Java is to JavaScript as ham is to hamster. So we start here with a fight with a lot of people cannot differentiate between what is Java and what is JavaScript, mainly the human resources people. But I prefer this one. JavaScript is to Java what fun is to a funeral. Mine, JavaScript is the long lie to TypeScript. I don't know if you can see the back of my laptop because that is the declaration of my intentions that for me, JavaScript is also a language that has multiple problems, and TypeScript is more or less one type of improvement. So now, a bit of storytelling. I did this course some months ago, so I want to apply it. So, true story time. The hero is a project manager. It was me in 2010, I think, when the first mobile application were rising, and a lot of different companies wanted to have presence or to have something in the App Store, Google Play. And it was a mobile project presentation for a banking company. And my counterpart, it was a senior master blaster of the universe in the backend world related with the banking mainframe, so very, very old-fashioned technology. For me, after explaining which is the project plan in that age waterfall, so design, requirements gathering, functional analysis, and so on. After that, I put a Gantt diagram with the different roles, project manager, analyst, designer, developers, testers. And for me, when he told me, I don't want your company to work with us because your proposal is no sense for me. And the main reason is that is a very small front-end application. We were talking about this banking first application, mobile application for their clients. And for him, it was not so important. Why? Because the mobile in that age has only 3.5 inches. So for him, the importance of any project belongs to the size of the view screen, for example. It was absurd anyway. But what I would like to put here is, it was the first example about front-end that is for nothing. And this is what he told me, and what I told to my boss. Okay, the dinosaur, it was the name that he has in this company, said mobile applications are a joke because it's a stupid front-end. But programming in COBOL is art. Exactly his words. So a bit of backend in history that I want to compare with the front-end one. So backend has evolved from the monolithic typical applications 15 years ago to now microservices and even microservices based on lambdas and a lot of different progression. So the complexity of the backend application has been increasing a lot during the latest years, and also the technology related to that. So we had monoliths, mini-lists, microservices, reactive microservices, and Lambda, and all the technologies related to that. I was working in the backend for more or less all my life. So I have experience with some of those technologies, are more focused on the .NET side. And also, we can see here that the latest thing is about Lambda and cloud, a native solution, and also CDN solutions. And what about the front end? So we had something that was named ECMAScript. It's the real official name of JavaScript. So we had the JavaScript hell. This is what I knew in the past. And later appeared ECMAScript 6, when we could say, more or less, now is first citizen language, more or less, in my opinion. And about the server-side rendering and client-side rendering, in the past we have ASP.NET, OSP, ASP.NET, JSP, and also Angular Universal, and next for server-side rendering. And about client-side rendering, jQuery, AngularJS is more or less deprecated, React, Vue, Electron, and also, and this is absolutely in my opinion, Node, TypeScript, RxJS, and also Angular in the end. So it's to put some context about this situation. Currently now, one thing that is trending topic is the microservices, but front-end with the microservices approach, micro front-ends, but for me they are not production ready. So, but anyway, it's something that is nice to talk about that. Okay, so which were the applications 10 years ago? A static web page that was with that horrible blink label in white and red, if you can remember that. So HTML, CSS, nothing about dynamic, nothing about JavaScript. Later we had ECMAScript. After that, server-side rendering. Just now, but since some years ago, single-page application, progressive web applications, and also exactly the same for the backend. The complexity has been increasing incredibly. Exactly the same for both. And now, again, micro frontends. There is a, but it's at the same time, I think, like mine, it's a talk about micro frontends I would like to attend to. And, well, because I belong in Malaga, my architecture team is more or less 99% of Java lovers. Some of them are here. I cannot say too many bad things. And the moment I say front-end architecture, for them is a Stack Overflow. Okay. So front-end is back-end. Let's compare a bit the difference between what we have on each side. JavaScript or TypeScript against Java or C#. I think the winner is clear, or the winners are clear. Frameworks. Angular framework, React ecosystem. React is not a framework. Also Spring framework, ASP.NET framework. I also think there is no too much to say about this, unless someone can say, okay, I think the things on the left are the best. Someone think that is the situation? Or do you all agree that what we have on the right is better? No? Someone say that what we have on the left is better? Yes? No? I only see one face. Is that mean that it is there? Okay. And what about data? I think here is not any competence, because the way of storing the data is very different. But one thing that is very important that is only happening in the front end, and the main one is the client side. Not technology people on the client side, but the final user, for example. They have the preferences, the colors, the fonts, I want that in this way, change that, I want this in another order. So a lot of different things that are not happening, never, in the backend. But also, what happened about the architects? My friends, I've been an architect working a lot of years in the backend. So this is a very well-designed backend diagram we have here. This is a class diagram with a lot of system components. Very nice, more or less. And of course, microservices. That is the best. It's the best thing in the world, microservices. If you say something backend, microservices, that is the best. And more and even more. Okay? So that is the backend. We can let aside, for example, about the infrastructure, about the different components. If we have, I don't know, RabbitMQ, Kafka, we have Akamai, we have different solutions. If it's a CDN or if it's a cloud solution. But in the end, we can say, okay, maybe this is the API. Okay? But this is something that cannot work alone, maybe unless it's a solution as a service. But if we have an overall solution, front end and back end working together, where is the design of the front end? It's there, but we had to do something. Front end. And that is the reason I have to work in my own company as the front-end architect evangelizer. I don't like that word. But why we don't have there something like what we have on the left? Okay. So let's see a real example. Very simple, very stupid, but it can illustrate what I want to explain. So we need a web application, very simple, accessing to an API endpoint to retrieve a list of items. Very simple, okay? So we have first here the monolith word. That is a word that I'm going to use a lot because it's real. The front end, or more or less, is always a monolith. And we can see here one component, okay, and one endpoint. In the end, an endpoint is a URL for us. And of course, the backend, super well designed, it's amazing, it's wonderful. You have a lot of time, a lot of architecture patterns implemented there. And for the front end, you don't have time to think, start doing that. Because it's the first thing that the client is going to see. And it more or less is always the same situation. Next step. Now, not only we need to access to that endpoint, but we need to show the information in another pages. Okay, so we are going to create inside this monolith different components. In this case, because the example is based on an Angular solution, those are components, visual components. In the end, HTTP pages and the controller also and the scripts. So we have different components accessing the same API. Components, visual components. No classes for accessing to the service is completely separated. Visual components accessing directly to the endpoints. And what is happening there? Each component more or less copy and pasting the way of accessing that endpoint. A lot of times what's happening is that maybe during the development, that endpoint is going to change, so you need to change that thing in 3 different points on your front-end application. And this is a very simple solution. Imagine you have one application with 2,000 components. I'm not saying a crazy thing. And imagine if you have a lot of copy and paste inside of them. Okay, so the backend, and now we are going to try to put this more complex. And remember, it's only 3 pages accessing one endpoint. We want to introduce another endpoint, okay? And so someone with a little more experience in Angular thinks that, okay, components are not the best way of accessing the endpoints, should be a service. Okay, let's use a login service to access that endpoint. And now, what is happening? We start with one thing that is very typical, are the God class. I don't know, who knows about what is a God class? No? One, okay. So you have a class for doing everything related to logging, for example. So you store the token, you manage the session, you validate the session, you are responsible for storing it securely. Also, you are responsible for holding the user data. So all the things are in only one class. That is a God class, doing a lot of different things. And in the moment It's the same picture before, okay, but I need more space. In the moment that we have more endpoints, we need also to share the information, because maybe we want to show on the top the username, and we want to show a specific page for the user. We need now to start to get information from another part of the code. What is happening now? The dependencies, I need to use that, cycle dependencies also, and relationships and dependencies between a lot of different components. So again, this is very simple. Imagine, multiply this by 10, by 100, and you will have a real front-end project. Oh, you are appearing in the last. Okay, so if front-end is chaos, almost always, you are right. Where do you think that we need more engineering? In the backend, that is so nice, so powerful solutions, or different frameworks, application, tools, or in the front end where we have this problem. So that's the main reason of this talk about my own work. And let's go back to what that manager told me, that development is art. I don't know, I was surprised when I asked this question some months ago in the University of Bratislava, that do you think that real development is art? They said yes. I can see one saying, who thinks that development is art? Can you please raise your hands? Okay. Only art or something more? Okay, for me it's not art alone. For me it's science. Do you know who is she? Margaret Hamilton. Some woman that that didn't have the credit enough she deserved. And if who can say who is she? Anyone can say who is she? Say please. Exactly. She was the main designer. She was not the only one, but she was the main designer, the main programmer for doing that. And imagine, no debugger. You didn't have any console dot log, sorry, for printing what is happening there. Okay. So, but she was the first one who talked about software engineering. In that moment, the only engineering thing related to IT was the hardware, because software is something not important. But she was the first one. What happened? And even today, a woman surrounded by 99% of men telling something that is new. You know how that is welcome, isn't it? But imagine 50 years ago. So for her, she was the first one to say that software engineering is a science. Okay. So, and as you said, she was the main responsible for the landing module and a lot of different things. And she was the first one who think about error management. The first one who thought about that. Okay. And as you have seen, I'm using some Lego pictures because I like them a lot. I have 2 children. And last year, Lego did this. They created this, honoring her. So that's one thing that I want to emphasize because of, for me, okay, first is science, is art, okay, but not only, okay? So again, software engineering. And why this word? And why is this concept so important? Because it's engineering applied to the software development. It's nothing, okay, I'm going to imagine, I'm going to sit, to put my hair in this way and in that form, to think that this is the way to create a form. No, it's software engineering. So why don't apply that to the front end? But again, front end is not only, also, backend is not only about coding. A lot of different things are involved in there. Okay? I'll talk later about that cube that is appearing on the left. So, as any other software development, systematic methods and methodologies, applying good practices, design patterns, why not? And taking decisions sooner, not later. So that means that try to think a bit, stop a bit, think on what you are going to do, not only on the, I know more or less, a lot of the times, the time is very demanding and you have to show something to the client as soon as possible. But dedicate for yourself a bit of your time and try to improve for later. Because if not, you will have that monolith that we have seen before. And also, very, very important, security. security. This is an end user solution. So performance, user experience, accessibility, SEO, and because architecture is about delivering a quality and reliable solution, it's again exactly the same for the front-end development. So I'm trying to put together front-end development and front-end architecture, and architecture in general. Okay, now only one hint about ADA is that Accenture Delivery Architecture methodology. I'm not here to sell anything, okay? So we have the counterpart that is TOGAF, is another organization where you can have your certification for Accenture, for architecture, but also in Accenture we have this methodology that I'm applying in my own projects. And it's again exactly about reliable and quality solution. So we have blueprints. You can say, okay, it's a checklist. You need to think security, performance, UX, that's all. But that came from a lot of people that have been working previously, not only on your own experience. And I'm breaking down all the complexity of any project. But I don't want to stop here, only to show that architecture is so complex that we have architect roles, that in my case, and even we have specialities in this case, front-end architect role. Also, we have DevOps architects. We have a different architects. So in the front end also, and even more breakdown. Okay. So let's return to our monolith. Okay, that is a nightmare. And what we have to do? So let's try. We have an API with 3 endpoints, for example. So we know about the technology we are going to use. We need to start to apply design patterns, good practices. We need to start to separate the different concerns, to separate the different responsibilities, to isolate, to avoid all the dependencies. So we have views and we have consumer of the API. Why don't we separate all of them? Why we have to put all of them together? So for me, this is a blueprint again, but it's a very high design. So you can apply it to any technology. In this case, for Angular, it's easier to implement, but also you can implement in Vue, in React, surrounded by all the libraries you need to put together with React, and any other. So a typical thing is that the projects are consuming the JSON from the URLs and are injected directly into the views. That is not a good practice. What you should do is to convert that JSON to your own model in the way you are going to use it in the view, maybe. But for example, a lot of times the backend is not only yours. You are sharing that backend with another different solutions or companies. So for example, if you need only username, email, and ID, for example, but the endpoint is giving me 20 more fields, I don't want to use that. So I'm going to get rid of those superficial information and to use my own models to pass only the information I need to the views. More things. State management. So no more storing information on the different components or on the local storage or wherever you want. Try, yes? And what now? Thank you. And yes, thank you. So, state management. For me, it's so important that even we have Redux, we have NGRX, we have a lot of different Vuex, a lot of different solutions that try to get rid of all the dependencies between the different systems and components inside this monolith. For me, it's mandatory always to have a state management, completely centralized and following a pattern, for example, the Flex one. Okay. Also, error management. Why each component needs to create again or invent again the wheel. Have a central error management for user transparency, for the error in your own code, for errors in the connectivity, and also the relationship between them. Routing also is so important, but can you see this structure? You can understand that this is important in order to have in the front end. It's more or less is covering not all, but mostly all the components and the main important things in a front end solution. So why do we have to finish always with what we have on the left? So do you agree? Do you still think that front end doesn't need architecture? Who dares? Anybody? You think that front-end doesn't need architecture? Any what? In Spanish, if you want. This is a proposal, because this is a top view. This is not implementation. And that is a good question, because it's a very high-level design. Later, you have to move that to the technology. So, for example, in Angular, is this example, we have very separate concerns about the components and the services. Okay? And we have modules to isolate all of them. In React, we don't have that. It's different. We have visual component, and also we have React components that doesn't have any view, but have, for example, logic. We can use that. This is the high level. It's like the blueprint. Later, you need to implement that in your specific technology. And for example, if you don't want to use Redux, because your solution is not so complex about data management, you can get rid of state management. My recommendation is always to have a routing completely separate and error management. But this is not implementation. It's completely different. Architecture at this level is like, oh, this is so nice. Now it's up to you. Implement it. So my work is very easy in that way, because I can say 20 different boxes, and it's up to you to implement them. But later, also technology architects, like in my case, I need to move that to the technology. And thank you, because exactly is that what I have in the next slide. I move that design into the technical design. So depending on the technology, error management. This is a module, but in the end, it's a, well, in the code, it's a specific declaration, but here is grouped by what is related to the error management. But it's not only one class, a lot of different classes, a lot of different things related only to that. And I can move that. I can apply later different strategies like lazy loading or different static checking or whatever we want, okay? So, sorry, this one is another implementation of that high-level diagram, okay? But anyway, that depends completely on the technology you are going to use. And it's an example, high-level design, okay? So, nice and polished front-end. And this is the moment I like the most about always in my presentations, because this is the front-end, but we are talking in the beginning about a solution, isn't it? Where is the backend? That is the backend for me. If I think in the same way as the backend architect, that is what I have to do, isn't it? But that's not the situation. It's only a joke about what are always thinking about the front end. Nothing inside that is only a box. So let's have 5 minutes, because I was requested to apply some more or things related to the code, because I'm no longer a developer since some years ago. But I want to show you that front-end is not only about coding, okay? So let me start. And those are the things we are going to check. So this is the typical case. There is a problem in the front end because it's a nightmare, always. And I need to perform a code review, or a review of what is happening there, what we can improve, what we can fix, what we can do there to save the project. So a lot of different things related to code quality is there. I don't want to stop in all of them. But all the things, again, came from that blueprint, the blueprint we are applying. Security, I don't know if you know about OWASP 10, the main vulnerabilities that are declared today. Maybe tomorrow we have different ones. About testing, and whatever you can imagine you are going to find in the project. So let's start. Let me check firstly. This is a real project, but I've defaced it. So that means that I've removed all the information related to the client. And what I want to see, okay, I have to do this manually. Most of the times you have tools, but sometimes you don't have even time. So What is happening there? My first idea, okay, let's have a look to the project. So I have the source code here. I can imagine, okay, I cannot see so many. Let's have a look to the source file. Okay, I have up here, and that is not the way of doing that. But anyway, in the end, what I want to illustrate is the manual way of doing that, and after this, the automatic way of doing that. So the first thing, security, MPA audit. I hope, yes, I have Wi-Fi. So I'm going to perform, because each project has the dependencies, in this case, this is an Angular project, so we are using here TypeScript. And I want to check if there is any already known problem about security vulnerabilities. So the first thing for me is something that, oh, we can do that only with one command, yes, at least with 40 dependencies. So we can see here, okay, this is a real situation in a project. 261 vulnerabilities. Do you think this can be in production? It's in production. And you can see here this funny report about some of them are dev dependencies, so in production they are not going to be there. But if I find someone that is not for dev, okay. But in the end, the main thing is that I'm checking the vulnerability, and it's front-end, but it's not coding, isn't it? Another thing I would like to try is to check, okay, which version are you using in this case, Angular. Are you up to date? Mainly, the vulnerabilities in your dependencies. The dependencies are the libraries you are using. Okay, so for React, you have to pick up all the different libraries on your own, but for Angular, unless you need a third-party library, also, you need to check the security always. And most of the time it's because you are not up to date. Because with time, and even in this world about the open solutions and open software and open libraries, a lot of people are working on that continuously. So they fix the vulnerabilities mostly every day if possible. So, but let's check how is the current status of the dependencies that we are using. Not about security, but about outdated. Okay, so we have a lot of packages completely outdated. Well, not so much. But you can see here, this is another check that I'm performing. And also, again, this is something that it doesn't belong to one architect or to a designer. This is the responsibility of the developers. Because it's not only about coding. It's also about applying these things to take care about dependencies, if there is a new version of the framework, if there are well-known vulnerabilities, and it's not so complex to test them. And another thing, because for me it's very complex, or I can do that, but with a lot of time. Okay, I would like to see how the project is structured, not having a look to the folders. So I'm going to execute this command. It's going to analyze the source and it's going to check the relationships between the different components. Okay, and let's have a look here, because it's this one. This has been created automatically for me. So a lot of things I have to do manually. I can start searching for tools to implement this manual work. So I can see here that from the first side, that doesn't look nice, because maybe all the things are loaded at the beginning. Nothing about lazy loading. So, okay, there is only one module, no separation of concerns, no reusability. So, for me, very bad. And it's a first appreciation, and it's no more based on my own gut feeling. I can see it here and I can demonstrate that they haven't been separating the different modules or the different logic agrupations. And what about coverage? 0%, okay. Nothing about unit testing. What I can see here are the default classes. So no code coverage, routing, nothing, or the default one. So you can see here, I can see a lot of different information that can be analyzed for me automatically. And it's again one responsibility responsibility for the developers. So let's go back a bit now to that boarding theory I even explained to you. I need to go now a bit faster because we are running out of time now. So this is what I've been doing. Okay, let me check it again. Only 2 things, but there are a lot of them, and there are more than 100 points that we need to check. Okay, this is the previous screen. And now a bit about theory. S.O.L.I.D. It was the former idea I had about this talk, about the S.O.L.I.D principle, but I don't want to explain you deeply which are the S.O.L.I.D principle. I only want to mention that we have the single responsibility, open close, list code substitution, interface segregation, and dependency inversion. For me, Robert C. Martin is not the author of all of them, but he put them all together, and someone told him to order the principles to form the S.O.L.I.D world. Okay, so for me, only just a hint, please have a look to this, because this is so important, not only in any other place, but also in the front end. I don't want to stop in all of this, because it will require more time, and I want to focus on the latest things. Also, more principle, keep it simple, stupid, so don't overcomplicate the things. Don't repeat yourself, don't copy and paste, please. And no lo vas a necesitar. In Spanish, you are not going to need it as American. That means that you always have to think on what we are going to do later, because that will allow you to prepare your code thinking on that, but don't give more functionalities than you have been asked, okay? For me, in the moment you can master all these different concepts and even more, for sure, because it was my previous experience, that you can be a happier developer than dealing always with those nightmares. Okay. And one quick thing is that because I'm searching for automation, not about the tools, I'm searching for how my own work can be automated. One thing that is more or less new, it has 2 years, I think. The cognitive complexity is something that is a way of using an algorithm to say how your code, the complexity of your code for your brain to be understood. So that means, okay, I can have a look to the code, no idea what is there. I cannot understand that. So console log, point, stop, breakpoints, to try to see what is there. But there is a way to try to discover the cognitive complexity using an algorithm in only one step. And we are going to see that there. So what is cognitive complexity? This is what I explained, and you can see this piece of code. It has a very specific name I'm going to show now, but only having a look to that, okay, let me see what is there. You need to stop to try to understand what is there. Okay, you know, this is a Hadoop indentation. Okay, and I have a real case of this, and it's even worse. So, complex cognitive complexity to measure the understandability of the code. And the principles are that if you have a lot of different ifs in your code, that will increase the complexity. If you have a lot of for example, or nesting if, your code is increasing the complexity. Why? Because it's not the right way. You have to think, okay, this way, and you need to start to keep thinking on your mind to understand what is happening, and again, what is happening here, where this came from. So that is one way to try to understand with an algorithm what is happening there. So those are what is increasing the cognitive complexity. And this is the situation. Okay, I have to go to one place. I can see. Hello? No battery? Oh, okay. If you see this, okay, this is a fork. What I have to do there? You need to think. Okay, and what is this here? That or this. Always on the right, isn't it? Because it's a straight way. You don't have to think. Look, 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 look what is happening. It's a sequential way, sequential execution. The other one, nesting. Again, loop, switch, for, catch. What is more simple? With the straight away or that loop? Okay. Code. So you need to minimize this. And this is a real example. So this is how this algorithm is controlling how your, which is the complexity of your code. Very simple example. So we have an if, plus 1, 4, plus 1, plus another 1 because it's nested, and so on. And now this. So try to understand that. Okay. So you need to think. And this one. This is real code. Okay, so you need to start. We have 3, 4, one if, another if, another if, another if. It became a moment where you don't have any idea what is happening there. And how to do that with SonarQube. Let's have now a quick view to that. You are going to love this. Kitematic. Okay, I'm using Docker because I don't want to have my machine with a lot of different software and solutions. I have a Docker for a comp.SonarQube is here, so I'm going to start this component, this container, sorry. And once it's finished, what I want is to have a look to what I've been talking. Anyone here knows what is SonarQube? Yes? So imagine that I can analyze my whole project in a different ways, controlling different factors, quality gates is the name for that, automatically. And that can be integrated in your continuous integrations and delivery system. So that means that you can repeat it again and again and again and again automatically for you. And let's have a look to real projects. We can start, those are real projects I've been working on this year. I've removed the names of the companies and so, but you can see here a lot of different fail. And I would like to focus on this one, open source code. It's checking for me, this cyclomatic complexity is another type of complexity. 68% of duplicated line of code. What is that? Most than the half of the projects is based on copy and paste code. So let's have a look at what is happening here. So, okay, here we have the Hadouken, for, if, else, is, let, and. So what this is doing is creating a table. For each cell, they have a copy and paste. For each row, they have a group of copy and pasted. And this is the real code. So imagine, if you need to understand what is happening there, to fix something or to add maybe another column, what are you going to do? You are going to copy and paste and to create another column. If not, you have to get rid of completely of the code you have there. But copy and paste is again not the solution. So this is only an example of how a software can automate this type of checkings. And now I want to do this project. No, this is another one based on React. This is a React project. So let me check the coverage. Because I'm going to send a report to SonarQube, but for this project. Hub connectivity service that is checking me for some things, but I want to change that. I want to access as an admin, and I'm going to tell to the software that I want to check a lot of different things. I'm going to change the quality gates and replace them by another more deeply and exhaustive check. And what I'm going to here is now we need to run the sonar scanner. Cool. The port. Okay. Now is performing a production build of the project, checking the coverage of the unit testing, end-to-end testing, checking the code smells, checking the vulnerabilities, checking the WAF stem, checking the critical, all the linter rules that you have put on your project that in the end, nobody cares about 100,000 problems or warnings here always. But for me, it's another recommendation to get rid always from all of them. So if it is finished, okay, it has finished. So we can go to SonarQube. And now we are going to see here a lot of more information that has been checked now, if it's working. Okay. Okay. So we have here now a new analysis, and it's checking the cognitive complexity. So this number is greater than 50, so let's have a look to what is there. Source, maybe this one, maybe this one, maybe this one, 26. So in the end, what I want to show is that, again, it's not only about coding, also it's related with the code, but it's something that we need to take care of, also in the backend and in the front end. Code coverage, okay, this project is, so there's one that is not correct. Bundle analyzer, this is not running. And here is a real example of a code review I did for exactly this project for one company, Acme, it's not the real name, and all the different points that I checked using my blueprint. So you can see there that, and even this is an export from Confluence, so this is a real project where they have been working on this project code quality review. So we have here that, hello. No. Hi. Well, I think I have only 1 minute, so, but I want to show you that we have a lot of different ways of analyzing what we have in different projects, and that is what I want always to insist on, not only for the backend, okay? And very close to the end. What is there? Okay. So what we have seen from the architecture, reliable and quality solution, to design a robust architecture, solid design principle, and the strong metrics that we have seen in SonarQube. Also, this is another way of explaining that, but it's missing some very important thing, that we work with people, and projects are not always about technology only. That this is the name we use here, the cuatro jineles del anti-apocalipsis. It's about the fourth item is the team. So empathy, be considerate, because maybe you are not the only one who have to debug your own code. Maybe you have to debug another people's code, as bad as yours. So imagine if you don't have some empathy with that. So to finish, this is the summary of my presentation, and just for you to remember, from the architecture, that crazy guy that we are talking, that the front is something not so bad. Legos, remember it. My presentation is about Legos, the robots and cubes, and the front-end dancers. This one, okay? So from my community, and thank you very much.